So good morning, everyone. This is lecture number 6. We are dealing with acceleration, and everyone is looking great today in good spirits. And let us start this class. If we can just recollect what we had done in the previous class. In the previous class, we were discussing concepts of average speed and average velocity. We had revised the concept. Average speed is total distance divided by total time, and average velocity is total displacement divided by total time. Do you remember this question that we had done in the previous class? Yes or no? Remember this question? Let us now try to introduce the next concept, and the next concept is the concept of acceleration. What do you mean by acceleration is the first question that I'm going to ask. What do you mean by acceleration? Yes, my dear friends, what do you mean by acceleration? Acceleration. What do you mean by acceleration? That is the heading for today's class. Acceleration, normally denoted by the letter A with a vector sign. That means it is a vector. What is an acceleration? And what does acceleration do? Can I have your thoughts, please? What is acceleration and what does acceleration do? Any thought is a good thought. And you don't have to worry about whether it is a right thought or wrong thought. Right or wrong are basically relative. For someone it might be right, for someone it might be wrong. What do you mean by acceleration? What does acceleration do? Yes, you know it. You have studied in 9th standard. We are not doing anything extraordinary. Yes. No one knows it from any class? That's quite strange if you have not heard about the term acceleration. Anyways, acceleration is the rate of change of velocity. When velocity changes with time, that is what we call as acceleration. I hope that you are writing it. It is the rate of change of velocity with time. Whenever your velocity changes with time, we call that body as accelerating. Now, when I talk about rate of change of velocity, this velocity is a vector. This velocity is a vector, so it can change in magnitude or it can change in direction. So it can change in any of these or it can change in both. So in all the three different cases, we will call that the body is accelerating. Acceleration means the rate of change of velocity. If the velocity is changing in magnitude, it is acceleration. If the velocity is changing in direction, it is acceleration. It is changing in both, it is also acceleration. Do we understand this? Yes or no? Have you noted this down, bacha? Okay, great. What type of quantity is acceleration? It is a vector quantity. Whenever I say it is a vector, it must have two things. One is the magnitude, and equally important and probably more important is the direction of acceleration. The SI unit of acceleration, everyone knows, is meter per second square. The dimension is LT minus 2. We all understand this? We all remember this? SI unit of acceleration is meter per second square and the dimension is LT minus 2. That is acceleration. Now, as you can see, acceleration changes velocity. Velocity can change in magnitude. Velocity can change in direction. Velocity can change either in magnitude or in direction. Now, how do we understand which acceleration will do what? So, we can understand it like this. Velocity changing in magnitude only. When will velocity change in magnitude only? So I can give some example. If velocity direction is like this, acceleration direction is like this, that means they are in the same direction. They are in the same direction. Velocity and acceleration are in the same direction. Velocity will increase. Do we understand this? That is how you can change velocity in magnitude only. In this case, this acceleration is known as positive acceleration. You might have heard about the term positive acceleration and negative acceleration. This type of acceleration where velocity and acceleration are in the same direction, my dear friends, is also known as positive acceleration. If velocity and acceleration are in the same direction, velocity will increase. We call it positive acceleration. How can you decrease the velocity? If velocity is like this and your acceleration is like this, do we understand this? They are in opposite direction. In this case, what will happen, my dear friends, is your velocity is going to decrease. People call this acceleration also as negative acceleration. We call this acceleration sometimes as negative acceleration. The other word for negative acceleration, do you know the other words for negative acceleration? Oops. The other words that I use for negative acceleration, the other word that I use for negative acceleration is retardation. The one more word that is used is deceleration. Have you heard these two terms, retardation and deceleration? These are the terms that are probably used for positive or negative acceleration. So we must remember important point: positive, positive or negative, positive or negative acceleration refers to the direction of acceleration. Do we understand this? Whenever someone is talking about positive acceleration, he is talking about acceleration increasing the velocity. If he is talking about retardation or negative acceleration, he is talking about decreasing the velocity. Do we understand this? Yes or no? This is how acceleration can change the magnitude of velocity only. When I say only, it is not changing the direction of velocity, my dear friends. It is only changing the magnitude of velocity. Do we understand this? That is the first thing, positive or negative acceleration. Acceleration changing velocity in magnitude. What would be the second thing that we must see? Everyone has noted this down? Velocity changing in direction only. Velocity changing in direction only. So I do not want to change the magnitude of velocity. I only want to change the direction of velocity. In that case, how will be the direction of velocity and acceleration like? Remember, the most important thing that you must remember about acceleration is the direction of acceleration. If your direction of acceleration is perpendicular to the velocity, if your direction of acceleration is perpendicular to the velocity, that I will write. If your acceleration is perpendicular to the velocity, remember this, don't forget this, then velocity only changes in magnitude. It does not change in direction. Do we understand this? Here the velocity is like this, and acceleration is downwards like this. So now your velocity does not change in magnitude, it only changes in direction. So this body is going to turn. Now can you tell me in which direction it will turn? This has got nothing to do with physics. This is simple common sense. Your velocity is like this. Your acceleration is downwards. How will your body turn? It will turn like this. Do we understand this? We turn like this. So if I'm on a bike and I'm turning like this, my acceleration is like this. Do we understand this? Similarly, if you have velocity like this and your acceleration is like this, perpendicular, how will the body turn? The body will turn like this. Do we understand this? So this is how we can have velocity changing in direction only. It does not change in magnitude. It only changes in direction. And when does this happen? It happens when the direction of acceleration is perpendicular to the direction of velocity. Therefore, you must understand that the most important thing that you must remember about acceleration is the direction of acceleration. Do we understand this? Okay, great. Now we have seen one case in which in which we change the magnitude of velocity. We have seen one case in which the direction of the velocity changes. How can I change both? Third point, velocity changing in magnitude plus direction. What can I do, my dear friends, so that velocity changes in both? I'll give you 1 minute. If I say my x velocity is like this, remember the most important thing about a vector is the direction. And if we forget or we don't consider that direction, that vector loses its importance. The most important thing about a vector is the direction. And as you can see, the direction of acceleration makes a hell lot of a difference. If it is in the same direction, it increases velocity. If it is in the opposite direction, it decreases velocity. If it is perpendicular, it changes direction like this, like this. How it can do both? How it can do both? Hmm? No idea? In first case, the velocity and acceleration were in the same direction. In second case, velocity and acceleration were perpendicular. So I've taken one case where angle is 0. I've taken one case where the angle is 90. So I can take a third case where angle is not 180 or 90 and your acceleration is like this. If the acceleration is going to be like this, it is going to change both the direction. I've just drawn one of the direction. It can be infinite directions. If the acceleration is like this acceleration is going to change both the magnitude of velocity as well as the direction of velocity. Can you first tell me whether the velocity will increase or will the velocity decrease? This is increase. This is decrease if you don't want to talk. Will the velocity decrease? Will the velocity increase or will the velocity decrease? the velocity will increase because the angle between them is acute. So you can remember, if the angle is acute, velocity increases. So velocity increases. What about the direction? How does it turn? Acceleration is like this, so it will turn like this. Do we understand this? So in this case, velocity will increase and it will turn like this. Now, if I make this case, velocity is like this and acceleration is like this. Now what will happen? Can you tell me? Here you can see the angle is obtuse. What will happen here? Is the velocity decreasing or is the velocity increasing? Velocity increasing, velocity decreasing, and yes, you got it right. Now you understand the concept. The velocity is going to decrease. How it is going to turn? Like this or like this? Yeah, see, it does not involve physics. It just involves common sense. It has to turn like this. Do we understand this? So physics is simple. Yes or no? Draw this diagram, fatafat, and then I'll give you a tabular form. If you want to write it in a tabular form, the tabular form comes here like this. So everything that we have discussed would be put in the form of a table. The table is right here on your screens. Have you noted it down, bacha? This is the table. If you want to write it in the form of a table, this is the table that you are looking at. The first case that we did was this pink one. Velocity only changes in magnitude. So you can draw a small diagram. Velocity is like this, and your acceleration is like this, vectorly. This is the case where velocity changes in magnitude. The second case that we did was velocity changing in direction. If you want to write in the tabular form, you can draw the velocity like this, and you can draw the acceleration like this, so that you understand. In the third case is the case that we did at the last. If you want to draw a diagram, you can just draw velocity like this, and you can draw acceleration in any given direction, not 0 and 90 degrees. Do we understand this? I'll give you 2 minutes to note this down. Everyone got this? Everyone wrote this? Yes or no? Shall we move ahead? Life has to move on, and we have to move ahead. Once we have understood what acceleration does, it can change the magnitude of velocity, it can change the direction of velocity, it can do both. Now we can move on to the types of acceleration that we are going to encounter. And I must ask you, what are the different types of acceleration? I hope your mic is working. I can see my voice echoing, so the mic is working. What are the types of acceleration? What is the first type of acceleration? Tell me, fatafat.
Uniform acceleration.
Yes, uniform acceleration is the first type of acceleration. Fatafat, keep on writing. I guess your NEET class is more intelligent and more dedicated and more hardworking than the JEE class. Well done. Uniform acceleration. What are the other names that I can use for uniform acceleration?
Magnitude and direction remains constant.
So I can call it constant acceleration, yes or no? Or I can also say that the acceleration remains same. Now I will try to describe what I see, what you said. Acceleration remains constant with time. Acceleration remains constant with time. When I say constant, it must remain constant in magnitude as well as direction. It must remain constant in magnitude as well as in direction. There is one more way in which I can understand this. Velocity changes equally in equal intervals of time. Velocity changes equally in equal intervals of time. Do we understand this? Yes or no? No or yes? This is known as uniform acceleration. I hope you have noted it down. This is same as what we had written for uniform velocity. Velocity remaining same or constant or uniform with time. Uniform speed, speed remaining constant or same with time. What is the next type of acceleration that we might encounter?
Uniform acceleration.
Uniform to this one. That was the first one was uniform. The second one is non-uniform. You did not say non. Non-uniform acceleration. What is the other term that we can use for non-uniform? We can use the term variable acceleration. So how do you say the body is moving with non-uniform acceleration? The acceleration changes with time. Acceleration changes with time. When I say changes with time, it can change in magnitude, it can change in direction, or it can change in both. So either it changes in magnitude, it is non-uniform. If it changes in direction, it is non-uniform. It changes in both, then also it is non-uniform acceleration. Do we understand this? Okay. Let us go back to this uniform acceleration, and there was a point that I did not write or missed. Now, many a times when we talk about this uniform acceleration, students have this thought that if a body is having uniform acceleration, it is moving in a straight line. That is not the case. If the particle is having uniform velocity, then it is moving in a straight line. But if it is having uniform acceleration, it may be moving in a straight line, it may be moving in a curved path. So remember, uniform acceleration does not necessarily mean that the particle is moving in a straight line. Do we understand this? Uniform acceleration does not mean body moving in straight line. It may move in a straight line, it may not move in a straight line. Do we understand this? Similarly, if the body is having non-uniform acceleration, it may still move in a straight line. Okay. So uniform acceleration or non-uniform acceleration does not tell us anything about the direction of motion. It may move in a straight line, it may not move in a straight line. What is the third type of acceleration that we will encounter? Yes, what is the third type of acceleration? Say
Average acceleration.
average acceleration. Well done. Average acceleration, and we denote this average acceleration by A. It's a vector and it is put in a box, A double. Average acceleration. How do I define average acceleration? We must know it. It is total change in velocity divided by total time. Total change in velocity divided by total time. Now I can write the formula for average acceleration. Average acceleration is delta. Delta means change. V means velocity. Total change in velocity divided by total time. I can write this change in velocity. Whenever I say change, it is final minus initial. So I can write it as VF, final velocity, minus Vi, initial velocity, divided by time. I can also write it as V2, final velocity, 0.2, V1, initial velocity, 0.1, divided by t. You may also use V for final velocity and U for initial velocity. So your formula starts to look like this. Do we understand this? All are same formulae written with different symbols. Do we understand this? Okay, now I can take this one and take this one and see how it turns up. So it looks like this. V average is V minus U divided by T. Or I can write V minus U is equal to A average multiplied by T. Or I can write it as V minus U is equal to average acceleration multiplied by T. This is the formula that you would have seen in your 9th standard. Did you see this formula in your 9th standard? V minus U is equal to A average into T. You have seen and you have read this formula, but may not be in this form. There are two things that are different in the form that I have written. Firstly, I have written it in the form of vector. Secondly, instead of using A average, you must be using A. V minus U is equal to AT, or V is equal to U plus AT. I have written A average, you have written A. What is the difference? We will see that difference, but let us first note down the important points. Whenever we talk about average acceleration, it is always calculated over an interval of time. Do we understand this? Average values are always between 2 points or 2 instances or 2 occasions. Whenever you have 2 points between A and B, between now and then, between 0 and 5, between 5 and 10 seconds, that value is known as average value. Do we understand this? Remember, acceleration is a vector. The direction of acceleration vector, the direction of average acceleration here is same as delta V. That means it is not same as velocity. That is what we confuse. It is same as the change in velocity. In whatever direction velocity has changed, that gives us the direction of acceleration. Do we understand this, my dear friends? Yes or no? The direction of acceleration is not in the direction of velocity. It is in the direction of change in velocity. Remember this. That was the third type of acceleration. I hope you have noted it down. What will be the fourth type? Yes.
Instantaneous acceleration.
Instantaneous acceleration. We write this acceleration as a vector, and as soon as I write this acceleration as a vector, you must understand that whenever I have talked about acceleration, see, whenever I have talked about acceleration, I denote it by a vector. That means whenever I am talking about acceleration, which acceleration are we normally talking about? I ask you, what is your acceleration? Which acceleration are you going to tell me? Uniform, non-uniform, average, or instantaneous? Which acceleration are you going to tell me if I ask you what is your acceleration?
Instantaneous.
Yes. Whenever I ask you your velocity, you always tell me your instantaneous velocity. Whenever I ask you speed, you always tell me your instantaneous speed. Whenever I ask you your acceleration, you always tell me your instantaneous acceleration. So, what do you mean by instantaneous acceleration? It is the acceleration at any instant. What is your acceleration now? Or what is your acceleration at 5 seconds? Or what is your acceleration at 10 seconds? That is known as instantaneous acceleration. How do I find this instantaneous acceleration? It is dv by dt. Do you understand derivatives? Yes or no? You have calculated derivatives? Yes or no? Differentiation? Well done. Derivative of velocity, so I can also write it like this. It is the rate of change of velocity vector with time. The direction of acceleration vector, direction of a vector is same as dv. Remember dv, not v. That means it is also not same as velocity, it is same as change in velocity. Do we understand this? In whatever direction velocity is changing, the same direction we have instantaneous acceleration. Do we understand this? Now, if acceleration is constant or uniform, if the acceleration is constant or uniform, my dear friends, then acceleration does not change. At any time you find out acceleration, it will be same. Such type of motion is known as motion with uniform acceleration, which is the first motion that we are going to study. Motion with uniform acceleration. Motion with constant acceleration. Now, in case of motion with constant acceleration, acceleration is constant. So if you calculate the average value, that average value will come same as the instantaneous value. Do you understand this? The average value will come same as the instantaneous value because acceleration is constant, and then you can write this average value, which is now equal to instantaneous value, as v minus u divided by t. From there you get your formula that you had seen, v is equal to u plus at. But remember, this formula is only valid when it is valid, my dear friends. When is this formula valid? When is this formula valid? When When is this formula V is equal to U plus AT valid? It is only valid when? It is only valid when? Acceleration is uniform. Do we understand this? But the formula that we saw before that, this one, this formula is always valid. Do you understand the difference between the two formulae? In this formula, we have average acceleration. In the other formula, we have acceleration. So V minus U is equal to average acceleration into T. This formula is always valid, whereas the formula that you have seen in 9th standard is only valid when the acceleration is uniform or constant. We understand this? Yes or no? So this is about acceleration and how do you find out the different types of acceleration. Okay. Now, do you remember how did we do derivatives or differentiation? Do you remember? We just need one formula. What is the d by dx of x raised to the power n? Do you remember what is this d by dx of x raised to the power n? Do we remember this? This is a yes, this is a no. No, you don't remember it? No one? Okay, then let me not take that part. We will do it when we do this. I'll be taking a extra class and we will cover that in that class. So let us not take it now. Okay, let us move ahead with the next heading, and the next heading is types of motion with uniform acceleration. So I will write the heading equations of motion. Equations of motion, and remember these equations of motion are only valid for uniform acceleration. Uniform acceleration. Now these equations you have seen before also, and in this equation what we are going to do is we are going to write them in vector form, and that is the new thing that you have that you are going to study, and on the other side we will write them in the original form that you had seen. What is the first equation that you would have heard? The first equation of motion that you have heard, and if I write it, V is equal to U plus AT. Remember, this equation is only valid when the acceleration is uniform. Do we remember this? Do we understand this? That is the first equation of motion. The second equation of motion is displacement. I write delta R for displacement. You might have read it as S, but S I'm using for speed. Therefore, I use delta R for displacement. This is equal to UT plus half AT squared. Do we remember this? Equation number 3. Now, equation number 3 might look a bit extraordinary. You just remember it. In vector form, this equation looks a bit awkward, but this is how this equation looks like. We would not be using this equation, this vector equation anyways. So you can just remember it like this. The fourth equation that you can use for uniform acceleration is displacement in the nth second. Have you seen this equation? Displacement in the nth second. How much it got displaced in fifth second? How much it got displaced in fourth second? So the equation is, we will do questions on this, don't worry. We just write the equations in the vector form. On the left hand side, what you see is the equations written in the vector form, but this is not the way we are going to use them. I just have to tell them. I just have to tell you for your information. The way that we are going to use them is the way that we are writing it now. The way in which you would have seen the v is equal to u plus at without the vector. You have seen this equation, yes or no? Number 2, displacement. I can't use s, so I am using delta r is equal to ut plus half at square. You have seen this equation. Equation number 3, v square is equal to u square plus 2 times a into delta r. You have seen this equation. 2 times a into s, you would have called this. I am calling s as delta r. And the fourth equation, which you probably have not seen, displacement in the nth second, I will give you enough examples on every equation so that you become comfortable with all of them. But the problem with the equation on the right hand side is that in all these equations, every term that we see is a vector. Velocity is a vector, initial velocity is a vector, a is a vector, and displacement is a vector. But here we are writing them as numbers, as scalars. Now that is not correct. So therefore, we must use something for their directions, because without directions, vectors become useless. Do we understand this? Without direction, vectors become useless. So I have to use something for their direction. And what do we use for their direction? We use positive and negative for your direction. So what we actually assume is, if something is moving along positive x-axis, we will take it as positive, and something moving along negative x-axis, we will always take it as negative. So if the particle is moving like this, it has a velocity like this, we will take it as positive. If it has velocity like this, we will take it as negative. Do we understand this? This is the convention that we are going to use on the x-axis. This is what we are going to use on the x-axis. Similarly, on the y-axis, we will use the same convention, but in a different way, because it is now moving up and down. So I will take everything which is moving upwards as positive and everything which is moving downwards as negative. Now remember, I am not going to change this sign convention ever. So whatever is directed upwards will always be positive. Whatever is directed downwards will always be negative. Have you heard about acceleration due to gravity? Yes or no? G. Acceleration due to gravity. Have you heard about this? Now, sometimes you might have seen in some questions, when ball is thrown up, they take G as negative, and when the ball is coming down, they take G as positive. Do you remember it? Okay. Some books do it. When the ball is going up, they take G as negative. When the ball is coming down, they take G as negative. I don't do that. I always keep one sign convention, and that one sign convention will always remain true. And that sign convention is on your screen right now. This sign convention comes from what? This comes from your this comes from the original x and y. So that is how we have created this sign convention. I hope you understand this. This is your positive x. This is your negative x. This is your positive y. And this is your negative y. Everyone understands this? So if something is moving in this direction, I will on the x-axis, I will take it as positive. Do you understand this? Please note this down. If something is moving like this along negative x-axis, I will take it as negative. So if something is moving along x-axis, this is positive and this is negative. Similarly, if it is moving in the upward direction, it will be positive. If it is moving in the downward direction, it will be taken as negative. So that is how we have framed our sign convention, our sign convention for this particular chapter, and this sign convention will always remain same. I am not going to change it no matter what happens, because I don't want you to get confused ki, sir, why you are taking one time G as positive and why we are taking sometime G as negative. So I will not change this sign convention. I will always keep this same. We'll end this class here with one question that I will do. And this question is from your sheet that I have sent to you. This is question number 27. Are you doing the sheet, beta? Okay. Pakka na? Or this is just to make me happy that we are doing it, sir, and then you don't do it. No, I understand. You are very good kids, and I'm really proud of you. This is the question number 27, I think, from your sheet. I think we have done this. I don't know. Let us just remember, these are the type of questions that are most likely to come in your NEET exam. This is question number 27 from your sheet. I hope you have that sheet with you. You see that sheet? The correct statement from the following is: a body having zero velocity will not have necessary zero action, zero acceleration. A body having zero velocity will necessarily have zero acceleration. A body having uniform speed can have only uniform acceleration. A body having non-uniform velocity will have zero acceleration. This is how they confuse things. What we'll do is we'll think about this question and the other question. We will discuss this question in the next class because the time is over and I have to move on to the next one. Okay, so keep on doing the question that I have given to you. If you can just do the sheet that I have given, even if you can do only 15% of the sheet that I have given, that is much more than enough that you will need for any exam that you are going to face. So that is a task that I have given to you. Enough questions are there covering all sorts of problems, whether it is uniform motion, non-uniform, uniform acceleration, non-uniform. Every question is given under a heading. Gravity is given under gravity heading. Uniform acceleration is given under uniform acceleration heading. So you don't have to look for right now whatever topic we have done up till acceleration. You should be able to do all the questions above that. Do we understand this? And from tomorrow's class, when we do uniform acceleration, you can do all the question in the uniform acceleration section. Okay? Chalo then, I'll see you in the next class. I hope you enjoyed this. Take care and may God bless all of you. Bye bye, bacha.
Bye, sir.